Okay, number 3, I got to start out by adding these two together, and I have to give them a similar denominator by multiplying both sides by the opposite denominator. So I need to multiply this side by that denominator and vice versa. So that's going to give me this. Okay, so you'll see I multiplied both sides by the other denominator, and now I need to combine what's on top by kind of making them individual terms. So I need to multiply this out too. Then I need to FOIL the right. And then combine like terms for. Then I need to combine my x's. So my x's are this, and this, which is nothing. And then my plain old numbers are -17. And that's going to be over my new common denominator. Okay. Here is the simplified version of our problem, which is definitely worth a point or two. Okay. So the vertical asymptote is the 0 of the denominator. And what would make the denominator 0? Well, right here, that would be -1 and +3. So -1 and +3 coming through there. So that's x equals -1 and x equals 3. My horizontal asymptote. Okay, so in the beginning, and I think someone did this in study hall the other day, the degree of the numerator in the beginning appears to be 1, and the degree of the denominator appears to be 2. But that's not true because this is an addition problem. Here is your rational function. So the degree of the numerator here is 2, and the degree of the denominator is 2. So we're operating off of the rules where the degrees are equal. So when the degrees are equal, we take the ratio of the lead terms to get the horizontal asymptote. So I have a 1 here, and if I were to multiply through x times x, I'd have x squared. So it's just 1 over 1. So the horizontal asymptote is 1 at y equals 1. The intercepts, that's what I get when I make, I can get the y-intercept, actually, when I make x equal to 0. So when I make x 0, I get -17 over, let's see, if I put 0 there, I'd have 1, and I put 0 here, I get -3, and 1 times -3 is -3. So that's 17 over 3. But on a graph, like, it's easier to think about it as 5 2/3. So my intercepts are 0. 5 2/3. So it would be about right there. Now my my x-intercept is a 0 of the numerator. A little bit harder. So remember, if we have like x squared minus 4, something we know but we forget, it becomes this. So if I have x squared minus 17, in factored form, it would become this. Now it's easy to spot my zeros as negative square root of 17 and positive square root of 17. So I would say square root of 17, 0, and negative square root of 17, 0. And the square root of 17 is really close to the square root of 16. The square root of 16 is 4. So the square root of 17 is like 4.1. You could check it on a calculator, but that just means that it's a little more than 4 and a little less than 4. And now this is what I'd be graded on, all this information right here on the test. But if we plug that into Desmos, we get an idea of what the graph looks like. And there's all the points exactly where they should be, my 5 2/3, my -4.1, my positive 4.1, and all that. And my asymptotes right here coming up like this okay? And coming like this, and like this, okay? So just like we said, everything is right where it should be. Okay, very good. So that is that problem right there. So you can leave it like this, or you can go ahead and draw it in either way. Okay, number 5, I will walk us through it and do this all over again. Okay, so for 5, what I need to do is I need to divide these two. So my first step is always factor anything that I can. So I can see immediately that the bottom left can be factored. So what multiplies to 1 and adds to 2? That would be 1 times 1. Okay, so remember, I just reciprocal the second one, and now I multiply on top. So what I would have is, I would have 3, I'm going to multiply my 2 numerators there, and my 2 numerators are going to be, I'm going to have 3x, parentheses, x plus 1, over okay. So now I have this crossing out with that, which means that this graph has a hole at -1, or at x equals -1. And we talked about why that is in class. My vertical asymptotes, what makes the denominator 0? Which should be 3 and -1. My horizontal asymptote, okay, so the degree of the numerator would be, well, if I started to distribute, I get 3x squared. So that would be 2, and my degree of the denominator would be 3, because it would end up being x cubed. So you would use the rules of a proper rational function, which tells us that the horizontal asymptote is always, when it's proper, y equals 0. So I could start drawing some of these in. So I could draw in my vertical, my horizontal, and now my intercepts. So I'm going to quickly just erase these x plus 1s because they're gone now. And I should have done that before when I decided that this was a proper, rational function, because the degree of the numerator, now that it is in its most simple form, is 1, and the degree of the denominator is 2. It's still proper, but I should have crossed those out and determined it kind of to be a different proper. But either way, it ends up being proper. Okay, intercepts, the 0 of the numerator is 0, because if I put 0 here, that would give me 0. So my intercept is 0, 0. And then my y-intercept is what happens if I make x 0. Well, if I put 0 in here and on the denominator, as soon as I put it in here on the top, 0 divided by whatever I get on the bottom, -3, is going to be 0 as well. So it's both the x and the y-intercept, which makes sense because that's where the x and the y-axis cross. Okay, that's the only spot on the graph where you can have the same x-intercept and the same y-intercept. So now that I have solved for everything on the graph and I have it in its simplest form, I am done. If you did want to graph it, you can, but this is really the information that you need. Okay, I think it goes something like this. And this, and then this. Okay, let's see if I have time for 6. I think I will end up doing 6 and 7 in class. I will show you this one right here if you kind of want to look through my work that I did on that one. I got part of the way through it. I'll write in the rest of the answers for you, but let's see. The vertical asymptote is x equals -1. Horizontal or slant is y equals 2. And the intercepts are 5/2, 0, and 0, -5. And there is a hole in the graph, actually. This is a tough one. We will do it in class. There's a hole at -3, -11/2, or -5.5. That one is really pretty tough. Okay. Hopefully that helps.